Okay, let's dive in. Today we're looking at some really cutting-edge material on AV connectivity,
Mhm.
specifically the DVIGear DVI-2515 AOC active optical cable.
Yeah, and our mission really is to get to the bottom of a huge problem. How do you keep a perfect 4K signal completely intact when you're running it a long, long way?
Right, like across a lecture hall or something.
Exactly. Your standard copper HDMI cable just chokes out. After maybe 10 or 15 meters, you're done.
And the core challenge there is all about bandwidth. This particular cable we're looking at, it's designed to just shatter that copper limitation. We're talking
Okay.
data rates up to 18 gigabits per second.
And that 18 GBPs, that's the magic number. It's what you need to max out the HDMI 2.0 spec. It gets you that really crisp 4K at 60 frames per second.
With the really rich color, too, like the 4.4.4 8-bit.
Yep. Or 4.2.2 10-bit. It's professional grade stuff, maintained over distances that copper just can't handle.
So this is where the tech, I think, really flips the script. It's the optical advantage. This specific cable is 15 meters, but the platform itself can push that full 18 GBP signal up to, was it 100 meters?
100 meters, yeah, that's 328 feet. And it does it while staying fully compliant with HDMI 2.0, and this is crucial, HTCP 2.2 for content protection.
So how does it actually do that? What's the mechanism?
Well, basically, the signal stops being electrical. It's converted into light. The cable uses four tiny, discrete optical channels. They transmit light with these miniature lasers, they're called VCSELs, and then convert it back on the other end.
And that shift from electricity to light, that has to come with some other big benefits. I'm thinking about signal purity.
Oh, absolutely. Because the video data is traveling over fiber, it's totally immune to environmental noise. You get zero RFI, zero EMI interference.
So if you're installing in a sensitive environment, you're golden.
Exactly. Think
Yeah.
about a hospital with delicate equipment or a secure military installation. For them, having zero electromagnetic leakage isn't a nice to have, it's non-negotiable.
Okay, hold on though. If fiber is so great, so clean, why is this called a hybrid design? Why not just make the whole thing optical?
That is a great question, and it's really the key to the engineering. It combines four strands of what's called POF, that's a very flexible optical fiber, with six copper wires.
Ah, so there's still copper in there.
Right. The fiber handles all the heavy lifting, the high-speed video data, but the copper is still essential for all the low-speed communication, the EDI handshake, HDCP stuff, and most importantly, it powers the little lasers and sensors inside the cable's connectors.
And that hybrid design that actually makes it easier to install, not harder.
Way easier. The cable is incredibly flexible. It has a minimum bend radius of just 2 millimeters. I mean, that is ridiculously tight for a cable like this.
Wow.
Plus, it's plenum rated, UL-CMPOF. That means it's safe to pull through air handling spaces in buildings, like above a drop ceiling.
And they solve that classic problem of trying to pull a big HDMI head through a narrow pipe.
Yes. The docking connectors are detachable. So you pop the head off, and the cross-section you're pulling is tiny. It's just 12.4 by 10 millimeters.
That's very clever. You'd snap a normal rigid cable trying to do that.
For sure. And because it's so low power, it usually just draws what it needs, less than a quarter of a watt straight from the HDMI source, so you can forget about finding a plug for an external power brick.
We should probably just briefly touch on standards compliance here.
Sure, beyond the video specs, it supports the full professional digital audio stack, 8 channels of linear PCM right alongside the video.
And for anyone working on government or certain enterprise projects, it's TAA compliant. Plus, it's backed by a solid 3-year warranty from DVIGear.
All important details for the pros.
So when you boil it all down, what's the big takeaway here? I think the central insight is that these active optical cables are just. They're the elegant solution to the distance and bandwidth problem.
I agree. They perfectly blend the speed and, the electromagnetic purity of fiber with the practical flexibility and power needs that copper can handle.
It's the best of both worlds, really.
It is, and it sort of leaves you with a provocative thought to consider. Given that this tech is already pushing 4K 60p signals 100 meters in professional settings, what's next? What are the next consumer electronics where optical fiber might just unexpectedly replace the copper cables we all take for granted? Maybe blurring the line between your networking closet and your living room.